By the end of this video, you all are going to be experts on the thyroid gland.
You really can't talk about the thyroid without also talking about the pituitary gland and the hypothalamus. Both are located in your brain. These two glands make up what's called the hypothalamo-pituitary axis. Here's how the three work together. The hypothalamus releases a hormone called thyrotropin-releasing hormone, otherwise known as TRH. This then tells the pituitary gland to release the TSH, which is a thyroid stimulating hormone. And as the name implies, that hormone then goes to stimulate the thyroid gland to release the thyroid hormones. And these are called T3 and T4. The numbers indicate the amount of iodine that are attached to each. So this is triiodothyronine, and this is thyroxine. But who cares? Those are really long words, so we're just going to use T3, T4. These three glands together work on a feedback loop. So what happens is T3 and T4 go back to your brain and tell these two glands, we have enough T3, T4 so you can slow down on making TRH and TSH. We have enough. This is called a negative feedback loop because it's telling these glands to make less. And these are actually positive feedback loops because these hormones are telling the next gland to make more. So this cycle goes around and around and around and around all day, and it changes within minutes to hours depending on what your body needs. Right here at these two hormones, this is where the action is. T4 has one job, and that's just to hang out and be available because T4 gets converted to T3. Now T3 is the hormone that's biologically active. So about 20% of your body's total T3 is released from the thyroid gland. The rest of it, the 80%, is converted from T4. And this reaction where T4 is converted to T3 happens all over the body. So the thyroid hormone works all over the body, every inch. Your brain, liver, kidney, heart, lungs, stomach and pancreas, every single organ. So when each part of your body needs T3, what happens is T4 floats around, it gets converted to T3 here at each site. Wherever it works, that's where this reaction happens. And then when the site no longer needs T3, another chemical reaction occurs where T3 is converted to reverse T3. Reverse T3 is not biologically active, so T3 has been inactivated to no longer function, and then it just gets metabolized. It's okay if you're confused. This is a tough subject, so let's review the whole thing one more time very quickly, very simply. The hypothalamus releases thyrotropin-releasing hormone to the pituitary, and then the pituitary releases thyroid-stimulating hormone, which then goes to the thyroid and stimulates the thyroid to release T3 and T4. These hormones go and circulate in the blood to all of your organs. And then when your organs or your tissues need more T3, it will convert T4 into T3, removing one iodine. So 4 iodines, 3 iodines. And this one's the one that's active. When these no longer need T3, they then do another chemical reaction and turn T3 into reverse T3. And this is no longer biologically active. In terms of the feedback loops, remember that T3 and T4 also tell the pituitary and the hypothalamus to make less. That's a negative feedback loop. These glands tell each other to make more. These are positive feedback loops. And this all happens within minutes, hours, and these levels change depending on what your body needs. Pretty crazy, isn't it? Coming up next, more on Hashimoto's and Graves' disease.